Hi. Today we'll talk about the basics of probability and statistics. We'll understand the fundamentals of it and the intuition behind most of the stuff. Okay. We will start somewhere. Okay. With, let's say I give something like H T. Okay. This is data. It has no context. Okay. Unless I tell you what it is, it does not mean anything. It could be a first name of first alphabet of name of a person or anything. Okay. Just three letters. So now if I tell you tell you that this is the outcome of a coin toss, then that becomes information. Okay. So this is data. If you have context to it, that becomes information. Now let's say this is data, and we have given some context to it, and it becomes information. So data and information. Okay, so what statistics is all about is trying to analyze the data, interpret the data, make some presentation about the data, and try to infer the data. Okay, so now if we say this is the outcome of a coin toss. Okay, and if you wanted to try to find out what would be the next outcome of a task. Okay, now we have like heads, sets, and tails. If I ask you what would be the next outcome of the task, then it becomes probability. Okay, so which means that if you wanted to find out what is the next outcome, then it becomes probability. Okay, so and this is the coin toss. Okay, and the process which generates this data is called there is a process which generates this data, and the process is called coin toss, and if you wanted to find out the next outcome, it becomes probability. Now if I wanted to find out whether infer about the coin, okay, whether the coin is fair or whether the coin is what is the probability of this model, okay, then it becomes inferential statistics. So this becomes like if you try to infer about the coin, it becomes inferential statistics. Okay, and that's how the statistics and probability is related. So I'll just repeat. I'll just write it once again. Inference. So you have observed some data. Okay, that is where the real life or real world problems are. You will have observations about something. Okay, you will have observations about temperatures in a city. You will have observation about the quality of a products. Okay, and whether it is defective or not. You will have observations about something, and you wanted to make and understand the process which generated the data. So that process is called inferential statistics. So analyzing, presenting, inferring data, and is called statistical inference. Okay, and if you wanted to find out what is the outcome of the next task, okay, next client task, then it becomes probability. So probability is trying to find out the future events. Statistics deals about what has happened in the past. Okay, so this is analyzing the past. This is predicting the future. That's the connection between the probability and statistics. Okay, and let's extend this idea. Okay, and let's say I have a coin toss. Okay, and it has given me heads. Okay, let heads. Okay, now I wanted to find out if the coin is fair, which means if the coin is two-sided, where it is having one heads and one tails on the side, or it is just having heads, or it's a loaded die, a loaded coin. Okay, that's something I'm going to infer. So if you wanted to infer something with just one data, okay, I just tossed the coin once, and I got the result head. Okay, now what will be the probability of receiving a coin toss with heads as an outcome? It is 1/2. Okay, now if that is equal to 0.5. Okay, now let's say I toss the coin one more time. Okay, then again I get heads. Okay, then probability of getting two heads is 1/2 into 1/2. Since the events are independent, which means that the outcome of one does not have any dependence on the next, I can multiply these probabilities. Okay, then it becomes 1/4 is 0.25. Then let's say heads. I mean, like I again toss the coin, I again receive heads. Now the probability becomes 1/2 into 1/2 into 1/2 is equal to 1/8. Maybe it is becoming 0. Let me erase this. Okay, you got the point, right? We're trying to infer from the outcomes using the observations and whether the coin is fair or biased. Okay, let me erase it and come back. Okay, let's continue. I just drew it a little bit further here so that I can have some space. So I'll repeat. We are trying to find. We are trying to toss a coin, and we're getting some outcomes, and we're trying to infer whether the coin is fair, and that's what we call it as an inferential statistics. Okay, and this is what our examples. Okay, we toss the coin once. The probability of head is 0.5, and we toss the coin twice. The probability is 0.25. Okay, we toss the coin thrice, and probability of getting heads is again 0.125, and 4 times we got heads. Okay, and this is the probability. And similarly, we get heads 5 times, then 6 times, and 7 times. Probability of heads is equal to 8 times. Then probability of this is 9 times, and probability of 10. So which means that we toss the coin 10 times. And if you try to find the probability just by multiplying whatever we get for every every event, it is 1 by 2. So if you keep multiplying it kind of probably halves. And these are the probability of 10 coin tosses we receive. Okay, and this is the corresponding probabilities. If you notice, the probability is kind of it starts with 0.5 for the first time, then it reduces, then it again reduces, and it again reduces by half. Okay, and if you see that it's kind of drastically reducing. So what it really means is that the probability of getting 10 heads on a fair coin is relatively low, because if the coin is fair, probably if you are tossed it like probably like third, fourth time or fourth time, you might have got something different other than heads, because a coin which is fair, if you see and if you try to see if it's possible to get heads continuously 10 times, the probability kind of drops. Okay, and this kind of notion of probability getting dropped for something equally likely is very important when you try to do testings like this, whether the process is to understand the process or understand if the coin is fair or not. Okay, now in statistics what we do is we start with the hypothesis. Hypothesis is always something like anything which is supposed to be proved is called as hypothesis. So if you can claim something, okay, unless it is proven, it becomes hypothesis. That's the meaning of hypothesis. In chemistry, we would have learned something like Avogadro hypothesis, something that talks about the pressure and temperature. So anything which is proven, yet to be proven, is called hypothesis. Now, our hypothesis, let's call it as is the coin fair? Okay, the coin is fair. Sorry, the coin is fair. Okay, coin is fair is the hypothesis. And the alternative hypothesis is the coin is not fair. The coin is not fair. Okay. So what is hypothesis? Hypothesis something is a statement which is supposed to be proven. Okay, if in order to claim it. Okay, otherwise it just remains as a claim. So in statistics we have two hypotheses normally. One is called the null hypothesis. That is the status quo, where everything is fair, okay, and everything is normal. The alternative is something that it is not fair, okay, and everything is, the thing which you claim is, we believe that it is true is not true, okay, that's what is the alternative hypothesis. So another example is, suppose if you go, if a judge wants to make a judgment about a criminal, he starts with a null hypothesis that he is not guilty, because a judge does not always have to have bias to prove that someone is guilty. He can just start with the notion that the person is not guilty, and the advocates and lawyers have to kind of provide evidence that he is guilty. So that is why the null hypothesis is always status quo. Status quo is like everything is good, everything is normal, everything is fair in this world. That's the null hypothesis. Alternative will be the coin is not fair. Okay, in this example. Now, how does these two connect with each other? So we start with a question. Okay, is the coin fair? Is the null hypothesis with that we are trying to prove? Or let's say I have a coin. Okay, I have a coin. Okay, and I have a coin which has a head here. And let's believe that you don't know anything about this coin. Okay, and let's assume that it could be both heads in both the sides or both tails in both the sides. Okay. But what you have is the observations of this about this process. Okay, I just tell you that I toss the coin 10 times and you got the 10 outcomes here, that is 10 times heads. Now what you do is you start with, okay, what is the probability of getting head as the first time? Okay, if you know about, I mean, for any coin toss, we know that the probability could be 1 by 2 if it is fair. So you start putting the probability values, okay, and try to compute it, okay, and if you see the probabilities are kind of dropping as we see the probability I mean at the 10th toss, if you receive hits, the probability of that occurring is kind of very low. It started with 0.5 and we're ending with like 0.0097. So you see that there is a decrease in probabilities. So in statistics, what we call something to kind of quantify whether we can accept the hypothesis, whether it is true or false, or I should not use the word true or false, okay, whether I can accept or reject a null hypothesis, because it all depends upon the samples and the experiments you make. Like I'll again give an example, okay, intuitive example. Let's say I only toss the coin twice, okay, I only toss the coin twice, and the probability of the first is 0.5 and the probability of getting 2 heads is 0.25. Now, if you ask me the question, is the coin fair? Okay, then probably you might say that you don't have enough evidence. I mean, you haven't done enough experiment to say that it is not fair. So you will probably say the coin is fair. Now, when you have more experiments, okay, what happens is the probability kind of drops down. And now after the 10th task, if I ask you what is the coin is fair, then probably you would say. You will reject the null hypothesis, which means that it looks like the probabilities of happening, I mean, the probabilities of getting 10 heads is very low. So I would just reject the null hypothesis, saying that the coin is fair, and accept the alternative hypothesis, the coin is not fair. Which means if I have more samples and tests conducted, my results changes. So that's the reason statistics is always something. I mean, you can get wrong conclusions if you do not have enough experiments or enough data. So with 2 experiments, you might say that the coin is fair, but with 10 experiments, you might say that the coin is not fair. Okay, because the evidence shows that okay, it is not. I mean, the probabilities are very low, and that's the reason you are saying that the coin is not fair. Now, how do you make the decisions? Okay, whether it is. I mean, how do you take the cutoff? Okay. Of which probabilities you need to take and based on which you need to make decision. That cutoff is what we call it as the p-value, okay, or p-value with alpha. Okay, the cutoff with p-value with alpha we put together. We can use those information and try to make some decisions. So what is p-value? What is alpha? This is closely related to what I have done, but not exactly the p-value here. Okay, so the reason is if I had tossed the coin 10 times, I could have equally got 10 tails. The decision would have been still, I mean, still, and it's an unfair coin, okay, based upon the low probability. So there are 2 set of outcomes that is possible to tell something it's an unfair coin. It could be 10 continuous hits with which I can make a decision, or it could be 10 continuous tails. So if you try to add the probability of getting the both heads and tails, that becomes p-value. For example, in this case, let's take the p-value for like 3 heads. It could be like 0.125 plus 0.125. That like kind of I'm adding the probabilities of getting 3 heads or 3 tails. Okay, the p-value becomes like 0.25. Like it will be the addition of these 2. And that becomes the p-value. So you can assume that the p-value would be kind of sum of all outcomes with tails included. So heads plus tails, heads, tails, tails, heads, tails. So if you try to add these 3, then becomes the p-value. So let's assume that the p-value, let's say at this point, okay, let's take this, and let's take the p-value is 0.37 because it's probabilities of 6 heads plus the probabilities of 6 tails. Okay, so it becomes 0.37. Okay, now we use the term alpha in statistics to determine whether to accept or reject the null hypothesis. So what it really means, okay? So what it really means is that if you see the p-values, if it is kind of reducing, and you can say that if it is if the alpha is like let's say 0.05. So what it really means is that if your p-value is less than 0.05, which means that the chances of getting such low probabilities are very rare, which means if you look into the coin tosses, I have tossed 10 times, okay, and if you find that the alpha is less than 0.05, okay, and then you can probably reject the null hypothesis saying that the coin is fair. Why? Because if you look into the p-values and find out that it is less than 0.05. So in this case, let's say here the p-value is 0.0078. This case, okay, this case at p is equal to 8, this is the p-value. Now, if you have done the experiment 6 times, the p-value would be 0.37. So you would see that, okay, the p-value is 0.3 is greater than 0.05, which means that I would conclude that the coin is fair. That's the tricky part of statistics. So if you do not have enough evidence, okay, and you can just say that, okay, based upon my experiments I have done so far, I can either I mean, like, I can conclude that I'm not accepting the alternative hypothesis. That's the reason they use the term reject the null hypothesis or fail to accept. It's not like true or false. You cannot conclusively say that what you've done is exactly right, because if you do more experiments, your answer will change. That's the reason in statistics they keep the ambiguity in it. Okay, they say that okay, either you accept or fail to accept, or reject or fail to reject. Okay, you don't use the word that okay in black and white. Okay, yes or no. Okay, when somebody says I mean, like the alpha is like 0.5, you have taken 0.5, the probability is like 0.3, p-value is 0.3. Are you accepting the, I mean, like, null hypothesis? They will say, no, we will call it as fail to reject null hypothesis, which means if I do more experiments, I will change my own answer. So that's the reason they say that. Now, again, coming back to the example, if you see here, if I take alpha as 0.05, in the case of at the 6th stage, when the experiment I have done it like p is equal to 6, I would accept that the coin is fair because the p-value 0.3 is greater than 0.05. Now, if I do experiment like couple of times more at p is equal to 8, that is like when I have tossed the coin 8 times, I would have noticed that the p-value is 0.078. That is like probability of getting 8 consecutive hits plus probability of getting 8 consecutive tails. Both together it will be like 0.078. Now if I see this here, this value will be less than I mean like 0.05. The p-value is less than 0.05. So what happens is in this case I will say I reject the null hypothesis, okay, and accept the alternative hypothesis. So that's what, and say that the coin is not fair. So these things change over few experiments. Now, why do we choose 0.05? 0.05 is normally taken and I mean, because this probability is already we are talking about in like 8 consecutive hits, right? It normally occurs with very low probabilities. Okay, so that's the reason we're taking 0.5. If you really want to be very strict, we can take it as like 0.01, which means I will still not say that the coin is unfair until it goes below 0.01. Okay, so maybe I'll take a couple of more experiments to confirm whether it is really unfair coin. So this alpha values is what you call it as like 95% confidence interval or 99% confidence interval. So in order to make some decisions, if you say with alpha is 0.05, you say that at 95% confidence interval, I mean I am confidence, I am able to accept the null hypothesis or reject it. The same things which holds true. So if you want to be more stringent, which means that you are rejecting the null hypothesis only in extreme cases, like even below 0.01, 0.05, 0.02, 0.03, and you're waiting till 0.01. So if you go beyond that, I mean that will be very less of information to kind of take care. And what will happen is you most likely will end up accepting the null hypothesis if you go for very stringent. There is always a trade-off whether to use 0.5 or 0.01, or you can use 0.04 as well. Nothing harm. Okay, but generally, traditionally, we stick with 0.05 as alpha value to kind of make a decision. Okay, so this is in short the idea behind the difference between the probability and statistics. The probability is trying to find out the next outcome, or the chance of what's going to happen next. And statistics is all about trying to work with the observed data and trying to infer the process which generated it. And even in examples in real world machine learning cases, let's say you have observed like house prices, let's say 100k, 200k, or 50k, whatever it is, and you wanted to find out and build a model, okay, which generated this data, which means that, let's say I build a regression model or whatever as an example. If I'm able to generate create a model from this data, let's say it is having 3 bedroom and let's say bedroom, okay, and let's say we have a number of maybe square feet, okay. Okay, we are trying to give some weight to the bedroom. Let's say I give weightage to more weight to bedroom. Okay, let's say weight is 3, and for square feet, let it give weight is 2, and let's say I have its proximity to school. Let's say I give 0.5 to school. Okay, and I'm able to generate a model based upon the observed data. Okay, and if I'm able to create this. Create this model from this data, okay, then what happens is I will be able to randomly predict the house price for an unknown house. Like for example, if I get a new, if I get a features like I have a house which is having 3 bedroom, which is having like 200, I mean like 1,200 square feet of livable area, and it is proximity to school. Then if I plug in these values here, I will be able to generate what is the possible house price of it. So this process of trying to use the data and build the model is what you mostly do in statistics and machine learning or data science. Okay, you're trying to use the data and trying to build the model. And once you build the model, you'll be able to find you'll be able to predict what would be the house price. Okay, so that's the relationship between this data and the modeling. Okay, so this is, I think, is a good start to kind of understand what the basics of probability and statistics are, and we will go in detail about probability in the next session. Okay, thank you.